Hello everyone. I welcome you all to Startup Academy, your online gateway to success in ISS exam. This academy is exclusively for ISS exam. So yesterday UPSC released the cutoff marks of ISS 2025, and here on the screen we have the ISS cutoff. For general category, the cutoff out of 1000 marks was 430, which is 43% marks. But out of 1200, which includes the interview as well, it was of 660, which is 55% marks. So if we take in consideration the cutoff percentage, 43%, that doesn't mean that we have to gain only 43% in the exam and we'll pass the exam. We have to gain more marks in order to get up to at 55%, because between 430 and 660 marks, people may have scored more than 430 marks and much more than 660 marks as well, and those people are only called for interview. So 125 candidates were called for interview, so we'll consider that they all have got more than 43% in their written exam, then only they were invited for the interview. So we'll take our benchmark up to 55%, that we'll score 55% in our written examination only, and not we'll not wait for calling for an interview and then we'll score 55%. That is not our agenda. Our agenda must be that we should score 55% in the written exam, and after that we'll definitely be called for the interview, and we'll clear the interview as well. So now our focus is on scoring 55%, so we should set our target high, as well as we should start preparing, we should start gearing up, because many people who might have scored 125 were called for the interview. Those might have scored more than 430 marks, but they were rejected in the interview. So they are well prepared and they must be feeling very bad, since they have prepared for this, since they have been preparing for the previous time, and this time they were selected for the written exam, so they are well prepared. Our competition is that candidates, as those candidates as well, and our competition is other candidates as well, those who are right now preparing for it. So we must gear up and start doing our work right now, else we'll be left with very small time, and in that time we won't be able to clear the exam. So I would request you all to keep on watching the lecture videos regularly, keep on making your notes, keep on revising them, even the older topics such as econometrics, which is a vast topic. So keep on revising all of them and watching the lecture videos. And if you have any doubts, you can ask us. We are available for you. You can just text us once and we'll sort all your queries which you have doubt in. So our focus is on 2026. This percentage might increase in 2026. 55% might go to 60%, and day by day the competition is getting higher and higher. So that's it for the cutoff marks. Now let us come back to our sampling techniques. We have been covering the topics systematic sampling, and we have covered simple random sampling with replacement, without replacement, systematic sampling, and stratified random sampling. Today we'll do a comparison between all three of them: simple random sampling, stratified random sampling, and systematic sampling. This is a big derivation, so I want you all to pay attention, and we'll do step by step everything. So the topic for today is comparison between simple random sampling, systematic sampling, and stratified sampling. On the basis of linear trend. So we'll take a linear trend. We'll consider, assume that all units in the sample increases according to a linear trend. So this trend topic comes from the third part of our paper 3, which is time series. We'll go up to that as well. But for now, let us consider that all the sample units keep on increasing according to one trend. Linear trend is nothing but an equation of a straight line, which we all had done in maths, which is y is equals to mx plus c, where m is slope and c is constant. So now the linear trend is yi is equals to a plus bi, where I goes from 1 to capital N. This is the linear trend formula. So first of all, we'll do simple random sampling. For simple random sampling without replacement. Now we all know that the variance of simple random sampling without replacement is nothing but capital N minus small n upon n s square. Here we know that capital N is nothing but small nk. Now first of all we'll have to find the variance of y bar, or we can say the population variance. For population variance, let us consider that equation only. Yi is equals to a plus bi. Now dividing the whole equation by 1 upon n and summation over I. Yi is equals to 1 upon n into na, summation of, because there is no I present over here, so summation will be n only, and 1 upon n b, summation I goes from 1 to capital N I. So this will become capital Y bar, which is population variance. This will become A, and summation I is nothing but n plus 1 upon 2. The sum of a series is n plus 1 upon 2 into b upon n. Here n and n gets cancelled. So our y bar is nothing but a plus b n plus 1 upon 2. Okay. Now for variance. Variance s square is nothing but 1 upon n minus 1. Summation I goes from 1 to n. Summation yi minus y bar whole square. So here putting the values of this will be capital N minus 1. 1 upon capital N minus 1, summation I goes from 1 to n. Yi is nothing but a plus bi from the linear trend, and capital Y bar is a plus b n plus 1 upon 2. Here we have calculated the value of capital N, a plus b n plus 1 upon 2. So here a and a will get cancelled, and we are left with whole square. We are left with 1 upon capital N minus 1. Summation I goes from 1 to n. We'll take b out only. B square will come out because of the square, and we are left with I minus n plus 1 upon 2 whole square. Now taking summation inside, we'll get b square upon capital N minus 1. Then summation, we'll open up the bracket. We will get I goes from 1 to capital N, I square minus n, because summation here there is no I present, so summation will become n plus 1 upon 2 whole square. The value of I square, summation over square of terms, is n 2n plus 1 n plus 1 upon 6, and here it will be n plus 1 whole square upon 4. Now the value of n is very large, so this n minus 1 is also almost equal to n, so it will get cancelled with n. For large n, n is almost equal to n minus 1. Therefore, we have cancelled out. So we will get b square upon, let us keep upon aside, the LCM will be 12. So it will be 2n square plus 3n plus 1 minus n square plus 1 plus 2n upon 12. Now if we have taken the LCM 12, then this will be multiplied by 2, so it will become 4n square and 6n 4n square plus 6n plus 2, and this will be multiplied by 3, so it will become minus 3n square minus 3 plus minus 3 to the 6n. So minus 6n plus 6n will get cancelled, and we are left with b square upon 12, 4 minus 3 n square minus 1. Or we can also write it as b square upon 12, n square minus 1 can be written as n plus 1 into n minus 1. This is the formula for s square. Now keeping this formula in variance, variance of y bar WOR, which was nothing but 1 upon n upon n minus n upon n s square. This will be taking out small n common. We are left with nk k minus 1 upon nk n. So this will get cancelled, and here the formula was b square upon 12 n plus 1 into n minus 1. Here this n minus 1 will be cancelled from here, and we are left with n only. So our formula will be n plus 1 into n. Now this n can get cancelled with this. So our formula of b square will become b square upon 12 k minus 1, and n can be written as nk plus 1. This is the variance of y bar in simple random sampling without replacement case. And in this formula, let us take this as equation number 1. This is according to the linear trend. Now we will form a formula for systematic sampling. For systematic sampling, Yij is the value of unit at I plus j minus 1 into kth place. This was the meaning of Yij in systematic sampling, right? So now Yij will become I plus j minus 1 into k, where I goes from 1 to k and j goes from 1 to small n. We know that variance of systematic random sampling, mean of systematic random sampling is nothing but y bar I dot, and this is nothing but summation 1 upon n summation j goes from 1 to n yij. So if we put it here, 1 upon n summation j goes from 1 to n I plus j minus 1 into k, we will get a plus b I plus n minus 1 upon 2 into k. And this yij, it will be yij is equals to a plus b into this, because we are taking linear trend. So this is the formula for variance. Now variance of simple random sampling, variance of systematic random sampling is nothing but 1 upon k summation I goes from 1 to k y bar I dot minus capital Y bar whole square. So keeping the values here, variance of y bar systematic is nothing but 1 upon k summation I goes from 1 to k y bar I dot was a plus b I plus n minus 1 into k, a plus b I plus n minus 1 upon 2 into k. And capital Y bar, we have calculated here capital Y bar's value. It is a plus b n plus 1 upon 2. Minus a minus b, and capital N can be written as nk minus 1 upon 2 whole, whole square. Right, on solving this, we will get this value as b square upon 12 into k square minus 1, or we can also get b square upon 12 into k plus 1 into k minus 1. This will be the value of variance of y bar systematic. Now under stratified random sampling, again here yij is nothing but a plus b I plus j minus 1 into kth into k now, where I goes from 1 to k and j goes from 1 to small n. Let this be equation number 2. Here the formula is this only. Now y bar st, variance of stratified random sampling, is 1 upon n summation j goes from 1 to n nj yj. This is the formula for this. So now we'll take the formula, the variance formula. Variance of y bar stratified is nothing but n minus n upon n s w square, where sw square is the variance within the units in the sample, within the row which we were considering. So now sw square is nothing but 1 upon n summation I goes from 1 to n, j goes from 1 to n, sj square, and this can be written as 1 upon n into k minus 1 summation I goes from 1 to k summation j goes from 1 to n yij. Right? So opening the bracket yij minus y bar j whole square. So on putting the value of yij and y bar j, we will get 1 upon n k minus 1 summation I goes from 1 to n 1 to k summation j goes from 1 to n a plus b I plus j minus 1 into k minus a minus b k minus 1 upon 2 plus j minus 1 into k whole square. This will be the equation that will be formed. Now on solving this equation, we will get the value. Okay, let us solve it. A and A will get cancelled, and taking the B common outside, we'll get B square outside upon n k minus 1 summation I summation j, and in the bracket we are left with I plus j minus 1 into k minus k minus 1 upon 2 minus j minus 1 into k whole square. This and this will get cancelled, and we are left with I minus k minus 1 whole square, which is nothing but b square upon n k minus 1 summation I goes from 1 to k summation j goes from 1 to n, this I square minus summation I goes from 1 to k summation j goes from 1 to n k minus 1 upon 2 whole square. On solving this, sw square variance of y bar stratified will be b square upon 12 k square minus 1 upon n. Your k square minus 1 can be written as b square upon 12 k plus 1 into k minus 1 upon n. This will become our equation number 3. Now we'll compare these three equations. So first of all, we'll write variance of y bar stratified is to variance of y bar systematic is to variance of y bar without replacement. Simple random sampling without replacement. From 1, 2 and 3 we will get v square upon 12 into k plus 1 into k minus 1 upon n. Variance of y bar systematic from equation number 2. V square upon 12 k plus 1 k minus 1, and this is v square upon 12 k minus 1 into nk plus 1 from equation number 1. Since we are comparing, the common terms will get cancelled. B square upon 12 and k minus 1 will get cancelled in every case. And we are left with k plus 1 upon n is to k plus 1 is to nk plus 1. Now we can divide each variances. First was variance of y bar stratified, then variance of y bar systematic, then variance of y bar simple random sampling without replacement. If we divide each term by k plus 1 upon n into k plus 1 is to k plus 1 upon k plus 1 is to nk plus 1 upon k plus 1. These and these will get cancelled. Here nk plus 1 can be written as nk plus n, because we can write this as because this nk, which is capital N, is very large. So addition of a small value such as small k will make no impact. So it can become the bracket. So here also k plus 1 and k plus 1 get cancelled, and we are left with 1 upon n is to 1 is to n. These are the values that we get. So from this proportion we can tell that variance of y bar stratified, variance of y bar systematic, and variance of y bar simple random sampling without replacement. Hence, the most efficient variances for a linear trend is for stratified sampling, and then systematic sampling, and then simple random sampling without replacement. This is the comparison among the three of them, and this is one of the most important topics of this chapter. So we have completed this topic, all the comparisons with systematic sampling, simple random sampling, and stratified random sampling. Now we'll move further on ratio estimator and proportion estimator and regression estimator in the next class. We'll do them slowly one by one, and keep on watching the lecture videos and keep on doing the hard work. We'll be able to clear this year's cutoff together. All the best. Thank you.